Take note, key concept, reflection, stretch, and compression. The graph of any quadratic function is a transformation of the graph of the parent quadratic function, y equals x squared. So take note of the information here about reflection, stretch, and compression, but on the next few slides we're going to see this information in a little bit more detail. First, reflection. So we have two graphs shown. In blue, the parent function, y equals x squared, the blue parabola opening upward here with a vertex at the origin. And then in orange, y equals the negative of x squared. And that's a reflection. So as we can see here, it says the graph of y equals negative x squared is the reflection of the graph of y equals x squared. Graphs of y equals ax squared and y equals negative ax squared are reflections of each other across the x-axis. Stretch. So if a is greater than 1, note the two graphs here. This time the parent function y equals x squared is graphed in black, and then the stretched version with a vertical stretch is shown here in blue. The graph of y equals 2x squared is a stretch, I'd add a vertical stretch, of the parent function y equals x squared. And as we can see at the bottom, increasing the absolute value of a stretches the graph vertically and narrows it horizontally. Finally, compression. Here we see the parent function y equals x squared graphed in black once more, and then the blue function y equals 1/2 x squared graphed in blue. The graph of y equals 1/2 x squared is a compression of the parent function y equals x squared. And at the bottom, decreasing the absolute value of a compresses the graph vertically and widens it horizontally. The graph of any quadratic function is a transformation of the graph of the parent quadratic function y equals x squared. We can see that in these two screenshots. Note the vertex in both parabolas is at the origin, shown here in red. And as we look at the left, the minimum value, well, if a is greater than 0, the parabola opens upward. The y-coordinate of the vertex is the minimum value of the function. On the right, the maximum value. If a is less than 0, the parabola opens downward. The y-coordinate of the vertex is the maximum value of the function. That brings us to problem 2, graphing translations of f of x equals x squared. Graph each function. How is each graph a translation of f of x equals x squared? Part A, g of x equals x squared minus 5. So consider the graph shown below. The axis of symmetry is the line represented by x equals 0. Our vertex, well, let's note the parabolas here. Starting with the parent function in orange, f of x equals x squared, it has a vertex at the origin, 0, 0, and we're subtracting 5. So each point gets shifted downward exactly 5 units, bringing us to the blue parabola, which has a vertex at the point 0, negative 5. We translate the graph of f down 5 units to get the graph of g of x equals x squared minus 5. And part B, how about h of x equals the quantity x minus 4 squared? Well, again, starting with the parent quadratic function f of x equals x squared, shown here in orange, we would shift each point to the right exactly 4 units. That leads us to a vertex of 4, 0. So, as we see at the bottom, we translate the graph of f to the right 4 units to get the graph of h of x equals the quantity x minus 4 squared. Your turn. Part A. Graph the function g of x equals x squared plus 3. How is it a translation of f of x equals x squared? And part B. Graph the function h of x equals the quantity x plus 1 squared. How is it a translation of f of x equals x squared?